Okay guys, so this is going to be angular motion notes set number 3. So what I did is I just pretty much copied and pasted the formulas from last time because we're going to be using them a little bit in this also. But we got some new formulas down here. These are going to be your kinematic formulas. Okay, so back at the beginning of the year, if we were in linear motion, we had VF is equal to VI plus AT. We had VF squared is equal to VI squared plus 2AD. We had D is equal to VIT plus 1/2 AT squared. And we had D is equal to 1/2 times VF plus VI times T. Okay, now we're going to be in rotational motion now. So this is omega F is equal to omega I plus alpha T. So your omegas are your angular velocities. Your alpha is your angular acceleration. Omega final squared is equal to omega initial squared plus 2 alpha delta theta. Okay, delta theta is going to be your angular distance that's traveled in radians. So it has to be in radians. Everything in these calculations has to be in radians per second also, or radians per second squared. Delta theta is equal to omega IT plus 1/2 alpha T squared. And then you got delta theta is equal to 1/2 omega final plus omega initial times T. Probably won't use this one that much, just like we didn't use this formula that much. Okay, so let's jump right in to our example problems. So I'll leave this up here. I'll try and work them like that so we can look at them. See if that's gonna stay. Okay, so a tire rotates at a constant 1.7 radians for every 15 seconds. Okay, so we can get the angular velocity from that by doing radians over seconds. What is the tire's angular velocity? Okay, so omega is going to be 1.7 radians over 0.15 seconds. Okay, so we're going to use our calculator. And you get 11.33 radians per second. Now it says if the tire has a diameter of 70 centimeters, what is the linear speed? Okay, so from last time, your linear speed is going to be V is equal to R omega. Okay, so your radius of this, now you're going to have to be in meters. So this is going to be 0.7 meters when you convert it, and this is diameter. So your radius is going to actually be 0.35 meters because we're going to divide it by 2. Okay, so 0.35 times 11.33, and I get my answer, which is going to be 3.97 meters per second. Okay, so this is almost like a review question that we would have done last time. Okay, next problem. A flywheel speeds up uniformly from rest to 900 RPM in 2 minutes. Find the angular acceleration and the tangential acceleration of the rim if the flywheel has a radius of 0.5 meters. Okay, so the word at rest means omega I is equal to 0. Now we're going to have to convert this 900 RPMs to radians per second. RPM stands for revolutions per minute. Okay, so 900 revolutions to 1 minute. Okay, let's make sure we're not out of focus. Okay, so 1 revolution is 2 pi radians, and 1 minute has 60 seconds. Okay, so we're going to do 900 times 2 pi and divide that by 60, and you get 94.25 radians per second. Okay, 2 minutes. Your minutes needs to be in seconds. So this is T is equal to 120 seconds. Okay, now, so we have omega I, omega final. That's what that is. You have your time. So we can find our acceleration by using the first formula up here. Okay, so omega final is equal to omega initial plus alpha t. So 94.25 is equal to 0 plus alpha is what I'm looking for. Your t is 120 seconds. So we're going to divide, and we get divided by 120, and I get 0.79 radians per second squared. So that's how you find the angular acceleration. Now the tangential acceleration, we're going to go to our formula up here. It says AT is equal to R times alpha. Okay, so your radius is going to be 0.5, and your alpha is going to be 0.79. So 0.79 times 0.5, and you get 0.395 or 0.40, and this is going to be meters per second squared. Okay, so angular acceleration is going to be in radians per second squared. Tangential acceleration or linear acceleration is going to be in meters per second squared. Okay, so next example, it says a CD player spins at 8590 RPM. Okay, so we're going to have to convert that. So it starts from rest and it has an acceleration of 450 radians per second squared. How long does it take to reach this speed? Okay, so we need to convert that. That's going to be our omega final. Okay, so 8590 revolutions per 1 minute. 1 revolution has 2 pi radians, and 1 minute has 60 seconds. Okay, so we're going to put that in the calculator. 8590 times 2 pi and divided by 60. You get 899.54, and that's going to be radians per second. Okay, so we're given omega final, we're given omega initial, we're given the acceleration, we're looking for time. So we're going to use the same formula we used on the last one. Okay, to find our time. Omega final is this 899.54. Starts from rest, so that's 0. We're looking for time, so our alpha is 450 radians per second squared. And so all we're going to do is do this divided by that. So we get 2.00 seconds, or 1.9989, so it's close enough to 2. Okay, next one. A rotating machine has an initial angular speed of 1.6 radians per second and accelerates uniformly at a rate of 0.5 radians per second squared for 5 seconds. What is the angular displacement during the time? Okay, so we're looking for delta theta. So delta theta, we're going to use the so this is omega initial, this is our alpha, and that's our time, so we're going to use the third formula. Okay, so delta theta is what we're looking for. The angular displacement is 1.6 times 5 seconds plus 1/2 times your alpha is going to be 0.5 times 5 squared. So 1.6 times 5 plus 0.5 times 0.5 times 25. Make sure you do your order of operations, use your parentheses correctly. You should get 14.25 radians. Okay, the second part of that question says how many revolutions is this? Okay, so remember, 1 revolution has 2 pi radians in it. We spent time on that. When you divide, you need to make sure you're in parentheses, and you should get 2.27 revolutions. So once again, if you divide by 2 pi, you have to use parentheses around the bottom. Okay, so a DJ speeds up a turntable uniformly from 33.3 RPMs to 45 RPMs. In doing so, the turntable goes through 4 revolutions. What is the angular acceleration? Okay, so we have VI, VF, and your delta theta. So we'll end up using the second formula, but we got to do a lot of conversions. So 33.3 revolutions per 1 minute. Okay, 1 revolution has 2 pi radians, and 1 minute has 60 seconds. Okay, and we're gonna pretty much convert both of them the same way. So I'm just gonna substitute the 33.3 times 2 pi divided by 60. Okay, so omega initial is gonna be 3.49 radians per second. So all I'm gonna do is I'm gonna substitute the 45 right here. So 45 times 2 pi divided by 60, and I get 4.71 radians per second. Okay, so we're gonna use our second formula. So omega final squared is equal to omega initial squared plus 2 alpha delta theta. It says it makes 4 revolutions. So 4 revolutions, that needs to be converted. 1 revolution has 2 pi radians. A lot of conversions in these problems, sorry. 4 times 2 pi, so that comes out to be 25.13 radians. Okay, so we're gonna move on to our formula now. So we got 4.71 squared is equal to 3.49 squared plus 2. We're looking for alpha, and your delta theta is going to be 25.13. Okay, so when we go to solve this, we're going to square this. So 4.71 squared. We're going to subtract this number over, minus 3.49 squared. And then we're going to divide by 2, hit enter, divide by 25.13, hit enter. So alpha comes out to be 0.20 radians per second squared. Okay, last example problem. It says a flywheel slows from 250 RPM, so that's your initial velocity, to 150 RPM in 4.2 seconds. How many revolutions occur during this time period? Okay, so we're going to be using the last formula. Okay. So we need to convert these. So I'm going to do the same thing I did on the last question. Revolutions per 1 minute. 1 revolution has 2 pi radians. And then 1 minute has 60 seconds. Okay. So we get 26.18 radians per second, and then I'm just going to substitute the 150. So this is going to be your omega I, and your omega F is going to be 150 times 2 pi divided by 60, 15.71 radians per second. Okay, so it wants to know how many revolutions it's going to make in that time period. So we're given omega initial, final, and time. So we're going to use the last formula. Delta theta is equal to 1/2 times omega final plus omega initial times t. Okay, your omega final is going to be 15.71. Your omega initial is going to be 26.18. And your time period is 4.2 seconds. So your delta theta is going to give it to you in radians. So 15.71 plus 26.18 divided by 2. And then we're going to multiply by 4.2. And we get 87.97 radians. Now it says how many revolutions occur. So we're going to convert that. There's 2 pi radians to 1 revolution. So we're going to divide by 2 pi. So remember, when we divide by 2 pi, we're going to use parentheses, and we get 14.00 revolutions. Okay guys, so this is a little more involved than the last couple weeks. I've been gradually trying to build on it. So if you have any questions on this stuff, feel free to reach out and we'll come back with angular motion set number 4, which is pretty much going to be the same exact thing we just did. So have a good night.